Hey there, fellow number enthusiasts. Have you ever stopped to think about how we use numbers every single day? From counting the minutes until lunchtime to measuring ingredients for a delicious cake, numbers are everywhere. But did you know that computers, those amazing machines that power our digital world, have their own special ways of understanding and working with numbers? In this exciting adventure, we're going to dive into the fascinating world of computer number systems. We'll explore four main types: decimal, binary, octal, and hexadecimal. Get ready to unravel the secrets of how computers use these systems to store, process, and display information. Let's start with a system we're all familiar with, the decimal system. You might know it as the base 10 system. Why base 10? Well, it's because we use 10 unique digits to represent all numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Each digit in a decimal number has a place value depending on its position. For example, the number 253 actually means 2 times 100, plus 5 times 10, plus 3 times 1. See the pattern? Each place value is 10 times greater than the one to its right. It's a system that's been used for centuries, and it works pretty well for us humans. Now let's meet the star of the show in the computer world, the binary system, also known as base 2. Unlike the decimal system with its 10 digits, binary only uses 2, 0, and 1. That's right, just 2. You might wonder how on earth computers can do anything useful with only 2 digits. The answer lies in the power of combinations. Just like in the decimal system, the position of each digit in a binary number determines its value. But instead of powers of 10, we use powers of 2. For instance, the binary number 1011 represents 1 times 8, plus 0 times 4, plus 1 times 2, plus 1 times 1 equals 11 in decimal. In the world of computers, those zeros and ones in binary are like tiny switches that can be either on, 1, or off, 0. Each 0 or 1 is called a bit, short for binary digit. And just like we group things together, computers group 8 bits together to form a byte. Think of a byte as a computer's way of storing a single character, like a letter, number, or symbol. With 8 bits in a byte, we have 256 possible combinations. 2 times 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 2 equals 256, which is enough to represent all sorts of characters. Section 5. Octal, a convenient shortcut. Now imagine working with long strings of zeros and ones all day long. It would be enough to make your head spin. That's where the octal system, or base 8, comes in handy. Octal uses 8 digits: 0, 1, 2, 3, 4, 5, 6, and 7. The beauty of octal is that each digit can represent 3 binary digits. For example, the octal digit 5 is equivalent to the binary number 101. Octal provides a more compact way to represent binary numbers, making them easier for humans to read and write. Section 6. Hexadecimal, compact, and efficient. Last but not least, we have the hexadecimal system, or base 16. This system uses 16 digits, 0 through 9 and A through F, where A represents 10, B represents 11, and so on up to F, which represents 15. Hexadecimal is especially useful in computer programming because it allows us to represent large binary numbers in a very compact form. Each hexadecimal digit corresponds to 4 binary digits. For instance, the hexadecimal digit B, which is equal to 11 in decimal, is equivalent to the binary number 1011. Section 7. From decimal to binary and back again. Ready for some conversion fun? Let's start by converting a decimal number to binary. We'll use the number 13 as an example. To convert to binary, we keep dividing by 2 and noting down the remainders. 13 divided by 2 is 6 with a remainder of 1. 6 divided by 2 is 3 with a remainder of 0. 3 divided by 2 is 1 with a remainder of 1. 1 divided by 2 is 0 with a remainder of 1. Now we read the remainders from bottom to top. 1101. Voila! The decimal number 13 is equal to the binary number 1101. To convert from binary back to decimal, we use the place values of the binary digits, which are powers of 2. For example, to convert 1101 back to decimal, we calculate 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1, which equals 13. Section 8. From binary to hexadecimal and back again. Converting between binary and hexadecimal is a breeze. Remember that each hexadecimal digit represents 4 binary digits. Let's convert the binary number 101101110 to hexadecimal. We group the binary digits into sets of 4, starting from the right, 1011 and 0110. Then we convert each group to its hexadecimal equivalent, 1011 is equal to B, and 0110 is equal to 6. Therefore, the binary number 101101110 is equal to the hexadecimal number B6. To convert from hexadecimal back to binary, we simply reverse the process, converting each hexadecimal digit to its 4-digit binary equivalent. For example, the hexadecimal number B6 is equal to 101101110 in binary. Section 9. Why do we need all these systems? You might be wondering why we need so many different number systems. Well, each system has its own strengths and weaknesses. Decimal is great for humans because we're used to it. Binary is essential for computers because it reflects the on-off nature of electronic circuits. Octal and hexadecimal provide us with convenient ways to represent binary numbers in a more compact and readable form. They bridge the gap between the computer's language and our own, making it easier for us to work with and understand the digital world. Section 10. Number systems in the real world. Number systems are everywhere in our technology-driven world. Every time you send a text message, watch a video online, or play a video game, number systems are hard at work behind the scenes. They're used in computer programming, digital data storage, network communications, and countless other applications. Understanding different number systems not only gives you a glimpse into the inner workings of computers, but also opens up a world of possibilities for exploring STEM fields and unleashing your creativity in the digital realm. Section 11. Keep exploring the world of numbers. Congratulations! You've journeyed into the fascinating world of computer number systems and learned how decimal, binary, octal, and hexadecimal play vital roles in our digital lives. But this is just the beginning. There's so much more to discover about the power and elegance of numbers. Keep asking questions, exploring new concepts, and never stop being curious about the world around you. Who knows what amazing mathematical adventures await? Keep those number-crunching brains engaged and keep on exploring.